Welcome back to another episode of the Building HVAC Science podcast. It's our goal here at Building HVAC Science to create better, more knowledgeable HVAC and building performance technicians by helping the two professions to better understand each other with the ultimate goal, making customers happy and healthy in the homes they live in and the buildings they work in. Today's topic turns to the subject of indoor air quality. And our subject is putting the V back in HVAC and why you should care. In this episode, I chat with Kevin Hart, the founder of Haven, a startup that makes unique IAQ sensor control system. You'll hear from Kevin about his background as an electrical contractor and how he came up with the idea for Haven, as well as all the iterations the product has been through. In this episode, he describes RDCV, or Residential Demand Control Ventilation, and why it's important for contractors and homeowners to understand this topic. You'll also learn how a simple chemical compound found in most homes can convert to formaldehyde, which is a carcinogen. In the show notes, I have links to Kevin's website, to the Haven products at TrueTech Tools, and to mention of a discount code that's available for a specific bundle of products which contractors can use. It's also Kevin's contact info, his email, etc., and a link to a topic we mentioned, which is Grace and Corbett Lunsford's, Corbett and Grace, their HOMECHEM videos, which is a very interesting experiment that happened several years ago. Okay, anyway, let's get on with this conversation with Kevin Hart of Haven and why you should care about putting the V back in HVAC. Today I've got a good friend, Kevin Hart from Haven. Is it Haven IAQ now, Kevin?
Our marketing team says to use Haven.
Okay, just Haven. So Kevin's got this really cool, mellow voice. So I'll talk less this episode and let him talk more. And he's got a good sense of humor for me picking on him.
This is Kevin Hart, the Canadian, not the comedian.
Yes, there you go. Just a couple little shifts in there, about the same number of syllables perhaps, but not Canadian. So Kevin is going to be talking about his company that he founded. And I think it'd be good to get a little bit of introduction, some personal history, as well as introduction to your company.
Yeah. So I'm the founder and CEO of Haven, which is an indoor air quality product company. And before I started this company, I was an electrician. I was in the trades and decided that indoor air quality was an important piece that was missing from the market. And we couldn't measure, we couldn't see what's in the air that we're breathing. And so this became the area that I focused on about 8 or 9 years ago. So we're focused on measuring, which is with the use of sensors, controlling with the use of relays, and ultimately what we call IAQ management with the use of software. And we prefer the phrase active air management because not everybody knows what IAQ is.
Interesting. I like that spectrum of measure, control, and management, and that the management aspect comes from the data you get from the measurements?
Yeah, exactly. So it's also helping to guide from start to finish of an IAQ project. So our mission really is, from the perspective of the HVAC industry anyway, to help contractors and almost more so the technicians conduct successful IAQ projects from start to finish. So you can think about everything from, is there a problem to solve, being part of the measurement piece, to what is the right solution? Let's collect some data and help guide the technician or the HVAC contractor, the building science practitioner, towards what is the right solution for this problem. And then did we implement the solution properly? And surprisingly, there's a lot of times where you found the right problem, you installed the right solution, but it still didn't solve the problem because the way it was installed or some other consideration. And then the ongoing management. Part of the management is that, hey, filters need to be changed, things happen, the state of the home changes. And the first 12 months are a test of all 4 seasons and how those affect and are able to maintain that IAQ and the performance of the building.
I'm going to say that phrase that last you said there sets you pretty far apart from a lot of the other things that are going on in the indoor air quality market. Do you feel that way too?
Active air management was a phrase we came up with almost as a category because we wanted to be separate from the category of IAQ monitoring, because there's a plethora now of IAQ monitors on the market. There's search on Amazon, there's hundreds. Everyone's come out with one. But if you talk to these companies, they don't know how to solve the problem. They don't know if they detect an issue, how to solve it. And so what are you creating if you're not solving the problem? You're creating fear. Your intention is to improve human health, but you're actually creating anxiety. And so we feel that to be in integrity with the mission of the company, we had to get into heating and cooling controls, automation solutions. We had to understand and go deeper down the rabbit hole. And unfortunately, that's meant, I think the easy low-hanging fruit would be just sell this consumer device directly to homeowners on Amazon or at a retailer and make money. And instead, we've stayed in R&D for years trying to understand how do we actually solve the problem, which has been an interesting journey.
Sure. Takes a lot of wherewithal and adaptation. Can you talk, maybe not too much detail, but a little bit about how did you research this was the way to go? What led you onto this path you're currently on?
It was actually in the electrician phase of my career, being exposed to crystalline silica dust, which is a carcinogenic. It's concrete dust. It's when you're grinding on a job site and you're breathing that in. And so you're supposed to wear a respirator. The problem is it quickly disperses in the air and becomes invisible. And you could be in a confined space and still breathing it in, and it's cancer causing, so you don't want to be doing that. But you can't see it. And so for me, it was this light bulb moment of, hey, this invisible environmental contaminant can potentially harm me, harm human health, harm biology, and not just me, but all these other people who work in the trades who eventually do, after 30, 40 years in the trade, are fairly beat up and do get black lung and other conditions, asthma. And so that was the initial impetus for the company. And then over time, we had that focus on those fine particulates, those almost invisible little physical particles in the air, so PM 2.5. And because we're in Canada, we're in Vancouver on the Pacific Northwest, wildfires, forest fires are a big, almost annual occurrence now. So we really focused on, we're in a temperate climate, we're in a moderate climate where we don't get a lot of airflow in our systems. We have filtration, but it's never active during the summers.
Because the system's not running, right?
Yeah, we don't even have air conditioners here because it doesn't quite get hot enough. So that was the focus of the company. And even when we launched the product in 2020 and then COVID hit, that was the launch of the focus of the product. And it was quite localized to our region, to our backyard here in Vancouver, sort of the Seattle region of the world. And really, it's been the past 2 years when we could travel again and we met customers and we traveled and we went to conferences and events and the Passive House Institute, the US event in Texas, in Austin, and going to these various events in Florida at the symposium where our eyes got open to, hey, there's other indoor air quality issues. There's other building science parameters. There's other climate zones out there. And that's been really humbling. But it's also meant that we found what we believe to be essentially a new focus for the company, which is much more on the side of ventilation and the effect of chemicals. So that's something we also wanted to talk about and share, hopefully in the podcast today.
Sure. You've identified is there a marketplace for you, a gap that you can exist in? I think you described it at the beginning, the 3 or 4 step process. Is there a problem? What is the right solution? Did it work? And then how to manage. And again, I commented that is unique and I think very smart.
Yeah.
Congratulations.
There's a drilling down from this high level of we want to apply technology to the heating and cooling industry, which software and technology, it's a little bit newer. And specific, then you can drill down. It's Internet of Things. It's devices that connect to the internet, that produce data, it's sensors. And then you can drill down further to, hey, we want to be this end-to-end indoor air quality project management tool set that empowers technicians and contractors and building science practitioners to go out and run successful projects and prove the results happen to their customers and get satisfaction and referrals and do good in the world. But then if you drill down further, okay, but what specific issues are we able to identify and solve? Because each issue represents a lot of research and discovery and talking to experts and talking to people who are out there solving these issues and understanding what is their process to do so. What are the equipment that can address this? Where are all the edge cases? You also have to choose and prioritize as a small company what problem areas within this high, bigger vision, bigger mission are we going to tackle?
Sure. So why is it important to have ventilation?
This is interesting because I've sat through many, many talks about ventilation. And one thing that never seems to get discussed is so what? It's this okay, yes, we should do it. And yes, there's pressurization, it can be balanced, and there can be infiltration and exfiltration. Here's different piece of equipment. Everyone skips over this piece of, yeah, but so what? Who cares? And I actually see quite a bit, and maybe it's deeper into the Facebook groups, the private groups out there, I see all the time technicians just say, it doesn't matter. We don't do it. We cap it off. It's an issue. It's a liability. We don't touch ventilation. And there's, in the eastern half of the country, 80 million homes in the residential sector that probably have this attitude of ventilation's more of a liability than an asset for the homeowners who have to live there for decades. And so why does it matter? It matters because you've got, and this is maybe the science is helpful, but you've got the physical, the particulates in the air, and then you've got more the gases, the chemicals, and they go right through the filter. They are not captured by the filter. There are some potentially absorbent or carbon capture type filters out there, but they really get saturated quickly, don't do a great job. The only reliable way we know of removing chemicals from an indoor environment is to just bring in outdoor air and exchange the indoor stale air with the outdoor air that is void of those chemicals. And really, the chemicals, where are they coming from? I think that's another question. They're being off-gassed from the materials in the home. So everything from the paint and the drywall and the carpets and the flooring, furniture, anything you buy.
Pets.
Yeah. We breathe out VOCs. That's another thing a lot of people don't know. Yes, we breathe out CO2, and you can smell somebody's breath. The breath has an odor. There's VOCs. There's flatulence. There's all sorts of VOCs that we're emitting all the time, and cooking and all these things. So there are a lot of chemicals. There's a lot of VOCs in our homes, and they have no way of escaping our home. And especially as homes get tighter, that's just even more of an issue where we're chronically, constantly breathing in higher and higher levels of chemicals.
I want to go back to something where you said removing chemicals inside by air exchange. You did not say dilute or dilution. Is there a reason you chose a different word?
So dilution is the essentially process of exchanging gradually over time. So yes, dilution, certainly you want to bring in that air. Even mixing the air is a form of dilution.
But when you said exchange, that to me says it also exits.
Exactly.
That's what I'm heading towards, because dilution could just be bring in air. So there's supply only, exhaust only. Do you want to talk about that?
Yeah, I mean, you can't really bring in air without pushing out air somewhere else. Homes are containers, and you can't just keep shoving air in without air coming out somewhere. You're either pushing air in and then it's exfiltrating out, either through an intentional cavity where you might have a mechanical fan or ventilation or some passive duct that it's exiting out of. And that exfiltration could be going through your walls. It could be going through cavities around windows, doors, etc. Or the other way is you're exhausting air. You're pushing air out, and then you're pulling air in the opposite direction. And so then you're infiltrating. You've got outdoor air now potentially either coming in intentionally in as a result of that, or it's coming in through, again, cracks in your wall and around windows and doors and that sort of thing.
Crawl spaces, attics.
Exactly. And then you've got balanced ventilation, which is the concept of you have an equal intentional amount of air coming in as air coming out. And so everything's balanced. Then I think a lot of people would just say balanced ventilation is what you want. And that's not necessarily true. There is actually benefits to sometimes being positively pressurized. You would much rather have exfiltration in a hot and humid climate because that air has been conditioned. So you're pushing conditioned air out through the wall instead of bringing in moisture in through the wall, where it's then touching the conditioned air from the materials on the surfaces of your interior of your home and then condensing behind the wall where you can't see it and creating mold behind the wall. You'd much rather have that conditioned air being pushed out than coming in.
So it's understanding the building performance. And you mentioned like the FIAS conferences and other things you've gone to. We saw each other in person just a few weeks ago at the HR conference. You do a lot of research, and your team does a lot of research. Kudos on doing that.
Yeah.
Why aren't people doing more ventilation? You mentioned that a lot of people dismiss it.
Mm-hmm.
Why do you think it is that they don't do it? Just because you said liability? Do they think it's not something that's saleable?
I think there's two main reasons. One is they don't think it's important enough. And that comes back to, I think many people don't connect emotionally, personally with the problem. Like they don't understand the human health impact. And I didn't even really get to it in my initial approach of explaining it earlier. Really, these chemicals, but so what? Again, what do they do? There are chemicals. What do they do to us? And a couple of the shocking ones, and Joe Allen wrote a book called Healthy Buildings, and he has, I think it's chapter 7. It's my favorite chapter ever. Being in this industry for 8 or 9 years, I'd never heard somebody articulate, I think the chapter is called The Global Chemical Experiment, which is the one we're running inside of our homes. And he really speaks to some of the effects on human health, like infertility. And now really imagine you're a technician and you're talking to your customer, and it's a family and there's a mother, and you're talking about infertility, the chemicals in these are not fear-mongering tactics. There's research and there's evidence and there's books on this, and you can point people to these resources, but we're talking about endocrine disrupting, so affecting hormones, affecting estrogen, affecting testosterone. We're talking about cancer causing. We're talking about things that are very important to people, and it is very critical we don't breathe these. And it's not something that you might see a symptom, although you do see mild symptoms like eye, nose, throat irritation, headaches, high CO2 levels, coordination, nausea. There's some mild symptoms that some people do and some people don't experience, but more so it's these long-term chronic health issues that arise from a lack of ventilation.
Joe Allen was a guest on this podcast a few episodes ago, and I will put that in the show notes, a link to that one if you want to delve more into Kevin's reference to Joe. How about the HOMECHEM videos that Corbett and Grace did? Do you remember those?
Yes.
Is that a good source?
That was an amazing source. They actually bring in these spectrometers that are probably over $1 million of equipment. And they actually looked at all the chemical interactions that were happening. One of the ones Joe Allen points out in his book is during COVID, all of these ozone generators got installed in people's homes to kill COVID. Now that ozone, some people can argue that the ozone is okay, that, yeah, it's a mild irritant, but it does more good than harm. Okay, let's just buy that argument for a second, even though I would maybe not buy that argument.
Challenging, yeah.
You've got all these cleaning products that contain a lemon scent. It's everywhere. It's prevalent. You have it in your home for sure.
I don't, but...
You don't. The audience, somebody in the audience has it. So that chemical is called limonene. And when limonene and ozone interact with each other, they create formaldehyde. It is a byproduct of those two interacting. This is in the chapter of Joe Allen's book. And formaldehyde is cancer causing, and it's one of the most toxic chemicals that we know about that is actually common inside of a lot of our homes. So that's just an example of where two things that you could argue are good, when combined, create something that's definitely not good.
Very interesting.
You had asked the question of why do people not do ventilation? And just to round that off, it's, I think, A, because they don't really relate to and understand why they're doing it. And that's nothing against people. No one's articulating the human health impact. So first of all, there's that. And then second of all, there's a lot of friction to doing ventilation. There's friction because the strategies, the methods we have of doing ventilation, particularly in hot and humid climates, have the potential to do harm. They have the potential to bring in moisture. They have the potential to overload the system, either on a sensible or a latent basis. The home may not be able to keep up with the latent removal when the dew point outside is high. And as a result, mold could grow and the homeowners could feel uncomfortable and sticky. And these are issues that you get called back for, whether it's mold or whether it's an uncomfortable customer. And now there's not a great solution right now. We feel there's a gap, particularly in the residential market, to be able to address that. And there's a second gap, which is addressing it easily and affordably. But that's really what we've come to, is there's this big gap. It actually makes perfect sense why it's not being done very often. I just don't see a lot of conversation in the industry about the fact that we're not doing it. Being honest, we're really not doing this. And when we do it, it potentially is creating other issues.
You mentioned affordability. At the end of the podcast, we're going to give people a coupon code. So hang on. Or fast forward. Go right. I got good. Push the button, fast forward. That's fine. You might miss it though. You started to mention some of the equipment or solutions that are used. What some of the key ones you would talk about? I mean, obviously you have a product that you've designed for this application. Talk about the Haven system and accessory products that work with it to achieve this ventilation goal.
Yeah, I think it's important to discuss what are the pieces of ventilation equipment that somebody would go and install in a home today. And by the way, I'm not an expert. I haven't got a PhD in ventilation. Really, we've been learning from people in the field. We've been learning from what the data says, what it tells us, what we learn on projects over the past 9 years, and listening to people. who are experts talk about this for many, many years. So we're not claiming to be experts. We're just learning like everybody else. And what we see from the field is that people are installing HRV and ERVs, which is a balanced form of ventilation, which has this enthalpy or energy recovery factor, where you're rejecting some of the either moisture and or sensible temperature from indoors to outdoors. So you're helping maintain the indoor conditions. You've got ventilating dehumidifiers. That's a form of ventilation where the ventilation runs through the dehumidifier. It's amazing. It's a great solution. So that's critical for hot and humid climates as well. There's just dampers. There's just bringing in the outdoor air. And that could be through a little PVC pipe, or it could be through a bigger 10, 12-inch duct where it's controlled by a damper, whether it's open or closed, either for continuous or timed ventilation to meet ASHRAE 62.2. Those are the primary ways we see people doing ventilation. But there's other things like bathroom exhaust fans and kitchen hood fans and makeup air units that could form a more holistic part of this overall strategy. But those are likely already in the home when the home was constructed.
Yeah, and those are when they're exhaust. That means that the infiltration comes from perhaps a less controlled source, unless you do some kind of makeup air addition, which can be done too.
So actually where we live, it's very common to go with an exhaust-only strategy and to pull air in through the envelope. And we get away with it because our humidity and temperature is moderate. But that is a bad strategy. You would not want to, and that's regulatory. That's our building code, is that's acceptable. Although codes are changing, that would be an awful strategy in Florida, right? So things that work in one area do not work in another area due to that infiltration.
So it seems to me like you've been working with at least one design partner, contractor in Florida. Do you want to talk about that experience?
Yeah, and particularly Lucy, who's the director of product at our company, she's been working with dozens and dozens of various contractors in the field who have just personally going on this journey. It's incredibly inspiring how generous these people are with their feedback, with their time, with their openness to do trial and experiment by her request. It's jaw-dropping how incredible some of these individuals are. And so we've got Jenry Garcia in Miami. We got Tim DeStasio in the Carolinas. And we probably 30, 40 other contractors that we actively work with for feedback as we launch new features. And it's just incredible that these people are willing to help.
And is there a particular execution of the design for ventilation that they use that's molded around the same theme?
Yeah, we're seeing the approach that is being taken, particularly on the east half of the country in hot and humid climate zones, like 1 to 5B climate zones, is this use of a ventilating dehumidifier, is bringing outdoor air, running it through a duct, maybe 10, 12-inch duct, so you get enough CFM, through a Y connector, and it's introducing both the return air and the fresh air. They don't really have a chance to mix, but they end up going through the dehumidifier, typically a reheat whole home dehumidifier. And that ends up being a great solution because now you can take even very humid air. We like to talk more in terms of outdoor humidity as dew point instead of relative humidity, where the outdoor dew point temperature could be 65, 70 plus degrees Fahrenheit, where you would really struggle to bring that air in and keep it under control if you didn't have that dehumidifier to help remove the moisture out of that air. The other great thing about that solution is it is able to solve all three of the indoor air quality pillars. It has a MERV 13 filter for the particulates. It's bringing in that outdoor air ventilation component, and it's controlling humidity, and it's generating airflow constantly or on a timer. And so really we're tackling all of the indoor air quality pillars at the same time.
And just to have the listeners visualize, and we're recording video too, but we don't have any like slides or anything to show here. It's not a webinar. But visually, people in their mind, there's the Haven probe. What do you call that? That sits in the central air or sit in the return air?
Yeah, it sits in the return, and people call it the induct, but we think about it more as a whole home monitor. So unlike something that's on a desktop or on a wall, this is measuring all the air coming back through the return into the return plenum, and it's getting in this whole home snapshot of everything happening such that the equipment can control based on the measurements.
And it's sitting in the return so that it's assessing the air preconditioning, pre-filtration, pre-dehumidification, pre-cooling or heating. So you're getting this constant sample of what's going on.
Yeah, it's a representation of what's happening in the occupied spaces of the home. Air is moving at multiple meters per second. So you can imagine a meter in a second. Air is moving very quickly from where you're living in the home through the return duct to our sensor, to our monitor. So we're getting a very accurate, very real time. Maybe there's a 5 to 60 second delay between when you're cooking and when we can see it. But it's actually a pretty remarkable way to measure air quality. And there's a lot of issues. If you want to do it hyper locally, there's some reasons you would want to do that. Maybe you care about CO2 in your bedroom at night. But if you're just trying to get a whole home picture of what's happening, you'd need multiple sensors throughout the home, which might be located in areas that are too close to somebody breathing, or they might get unplugged or tampered with. And we've just seen a lot of issues, even the cost of multiple, and where do you set those up? Now you're a technician stumbling around the home trying to plug these things into outlets.
And perhaps they're close to sources, which will bias the results into not giving collective average information. Okay, so we have this sensor that's in the duct, which is your original product. There's no display on it. It wires up with 24 volts AC, and it transmits a signal to an app and the cloud, or directly. How does that work?
Yeah, there's both the app interface. So you can think about the cloud like that's where the data gets stored, and then that data gets pulled into the app and it gets pulled into the Pro Portal, which is a web-based portal.
For technicians, contractors, yeah.
Yeah, for technicians or service managers, where you can see all of the projects. Again, it's a project management platform. So you can see all the projects you've done, and we rank them. We show you when there's issues. So, hey, the filter needs to be changed in this customer's home, or actually the humidity is not being controlled in this customer's home. And that's either to maintain the integrity of that project that you did, or maybe that customer didn't opt for everything. And now you're seeing that there's a constant issue in an area that you never addressed. And that becomes a new opportunity where the homeowner and the technician and the contractor can get together and say, hey, look at this issue, keeps happening. Do you want to address this? So it could create opportunities.
And then going back to trying to lead people back to like our original statement, measure, control, management, active air. We got the measure down, the data. You mentioned IoT, it's sitting up in the cloud for contractors to view. And then there's also control. How does that happen?
Yeah, so we came out with a controller, and this controller also operates off 24 volts power, and it is a 2-relay controller. So think about how on the thermostat, you might have an accessory relay. And that accessory relay may or may not have a wire in the installation of the home. There may be a wire there for you to actually use that terminal, but there's typically only one of those, maybe two, depending on what thermostat you're buying. There's a limited amount of fundamentally relays on a thermostat, and there's a limited amount of wires that maybe are connected to those relays, such that you could control other things other than just the heating and the cooling system. So what we're trying to open up the opportunity to have additional relays. We see the opportunity to have a wireless product that can be attached to the equipment and can communicate to the monitor, and to have relays that are logic-based, where you can control the logic for managing indoor air quality specifically. It's not a thermostat. You can think about it more as like a health stat.
Healthostat. And then the relay would then connect to the active air management, which could either be a damper or trigger the ventilating dehumidifier, perhaps?
Yeah, exactly. And that leads in the app as you're installing our product onto a solution, like a piece of equipment, and you're setting up the controls, you're able to move through now several templates, which we're just launching. And so this is a big moment for us, because it was always choose your own adventure. What do you want to connect, and set your own thresholds? And you basically had to be an expert to use the product. We work with people who know what they're doing, the top 1% of people, which is great. But working with them, we realize that the process they follow could be followed by others if the process were laid out in an easy to follow fashion. So the app actually guides you. Here's what we're accomplishing. And we have a ventilating dehumidifier. We actually provide a wiring diagram on how to wire our product to their product. We provide thresholds that we've set through talking to pros. And first, we actually set those parameters looking at the existing research. We looked at science, we looked at the Environmental Protection Agency, the EPA's thresholds. So we did a lot of research, but working with pros, we helped refine those set points, those thresholds, those activation parameters. And so when you're going through this, we're going to say, here's what we recommend. You can edit it if you know better. You can edit those parameters, but we guide you through what is proven to work with other pros in the field.
That's very admirable. And I mean, you're really building on the shoulders of people who are out there solving problems, gaining experience, and then sharing the processes for others. That's by deploying it through software, through tech. Very clever. So are those your AA templates, you call them?
Yeah, we initially, at least internally, called them advanced automation templates. So how can we deploy? Maybe, because it probably won't make sense, I'll explain what that means. Because we've now identified a specific problem we want to solve, we understood that demand control ventilation is an area in commercial that's prevalent. In other words, when, let's say, CO2 is above a certain amount or VOCs are above a certain amount, then we can call for ventilation. But why call for ventilation unless there's some need for it? And then second to that is what's happening outdoors. Is this the best time to actually bring in that outdoor air? What is the outdoor air quality index? Maybe we're bringing in outdoor air that's more polluted than the indoor air because there's a forest fire happening. We added some advanced parameters where we can now know and control based on the outdoor conditions, the outdoor air quality index, the outdoor dew point, the outdoor temperature. And then similarly, on the indoor conditions, we can see what are the chemical levels. Do we actually need this ventilation? And we can start to create logic and algorithms and thresholds that operate in a more rules-based, advanced way than we previously made available. And by putting out polls and talking to experts and working with professionals who do this on a daily basis, we've been able to see the whole spectrum of how they set things up. You got really smart people like Michael Hausch who are playing with their own logic and seeing how they function. And we've been getting a lot of data back and noticing, okay, yeah, this is actually a no harm and a fairly reliable way of doing things. And this is the first time in the history of the company where we're seeing a pattern of this problem can be solved with a limited number of caveats.
Very cool. So if there's professionals out there who want to implement this, what would you call it? RDCV, residential demand control ventilation?
Yeah.
Okay, you can use that. No fees. So if you have someone who wants to implement RDCV, what kind of support would they get? Because there's a bridge that has to happen between where they are, just getting curious about it, believing what they heard here today, the research they do. What is the next step for them?
There's a couple of steps that we would recommend, and each of those steps has a level of support because we acknowledge that taking this on could be intimidating. You haven't done this before, and there's technology involved and software. And we help from the basis of support. We have a support team, we have a support number. If you create a pro account, you have access to that support number. It's easy to find. It's in the app. It's on our website. And that support number will get you a live individual. We have somebody 7 days of the week. And so if you're doing an install, you can call and someone will either pick up the phone or call you back within some short period of time while you're still at the home. We'd recommend first starting to do a personal use project. So we call it the personal use program. That's where you can get a device installed in your home. And that program, you don't want the first time you're doing this to be at a customer's home. And you also want a personal experience where you believe in the product, you understand what it's attempting to solve, and you can monitor and manage that your own home through the Pro Portal. And so that's an important first step. The second step we've seen, which is interesting, is now take it to a customer. But because you've never done this project for a customer before, actually either offer it for free or at cost and just get that project under your belt and now use that as essentially marketing. Now you can tell future customers, here's what my other customer has as a result of this project we did for them, and here's how it's worked out, and here's their testimonial. And so that's an important piece that doesn't get talked about much is how do you actually go from this is what I did for myself to here's what I do for my customers, and now you can start selling on the basis of those two things put together.
Very interesting. And to make it clear again to listeners, if you're not familiar with this at all, I'm sure some of you are that will listen, some of you are not. The measurement and control are really the two products that are Haven branded.
Yeah.
The management aspects are commercially available products that get connected to the control.
Right. And what we're seeing is that our first few templates are built around ventilating dehumidifiers because it's just such a great solution. And many of our pros, there's been a handful of installs, including one that happened a few minutes before this podcast in Oklahoma. Many of the installs have been done on the Santa Fe line of ventilating dehumidifiers. We've had a few that happen on the Aprilaire line of ventilating dehumidifiers, but most of them seem to be so far on the Santa Fe equipment. And so we are compatible with all ventilating dehumidifiers that we've seen and know about. And those, again, seem to work well. And we have wiring diagrams for how that works that are available. And we're close with those manufacturers. We talked to Santa Fe. I know you probably had Nikki on this podcast at some point.
Not yet. I got to put that down. Yeah.
Yeah. And so, first of all, from the perspective of Haven and our products and how this all works, we're here to support you. We'll also help you if you need help connecting with the actual equipment manufacturer and getting support on the actual ventilating dehumidifier from that perspective. And then we can also help you if you just want a pro who's been there and done this before. We can even help connect you. Those pros have offered and provide very generous feedback if you have any questions. And there's certain groups, Facebook groups, where you can post your project and get help from other pros who've been there and done that.
And you may also need dampers, though, in order to valve on and off the outdoor air. Any recommendations there? Those, again, commercially available products?
Yeah, so the damper we've found is a critical part of this. None of these ventilating dehumidifiers have the damper built in. Potentially Aprilaire has one that's actually built in, but you do need to go get a third-party damper, and that's going to be connected to your outdoor air duct, and it's going to open and close based on the controller. The controller has a relay that connects and can open or close that damper by energizing or de-energizing the circuit. And so that's critical because we need the ability to either say, yes, we want that outdoor air, and no, we don't. We also control the compressor, which is connected to the fan of the dehumidifier. So we can say, now's the time we want ventilation. We either run the fan or run the fan and the compressor on the dehumidifier, along with that ventilation opening. There's a lot of logic we can do to help manage indoor air quality and moisture and ventilation.
Can you use more than one controller?
So we're coming out with, it's in beta now, a second template that conserves more energy by knowing when to run the fan and when to shut off the fan independently from the compressor. And so there are times of the day where the dew point and the outdoor temperature is such that you could just open that damper and you could run the fan. You don't need the compressor. You don't need the additional energy, which now you're reheating through the heat pump and now it's kicking on the air conditioner. So there's a lot of additional energy that goes into dehumidifying the air and everything that happens after that. What if we could just use the damper as an economizer and bring in air when it's suitable to bring in that air? That's something we're doing. And then that leads to another template that's a little bit further out, but is coming, which is if your customer doesn't have a budget for a ventilating dehumidifier, and not everybody does, what about just an outdoor air damper that opens and closes when the time is right, where it's not continuous ventilation, where moisture could build up mold and do harm. It's not no ventilation, but it's more of like an opportunistic ventilation. It's an economizer. It's let's bring in free ventilation when there's really no impact on the load inside of the home, such that we can handle it. We can handle this outdoor air.
In that situation, you need to know outdoor air conditions. What sensor?
The sensor inside, first of all, could say we need ventilation. And unfortunately, like the pro and con of this is that with this setup, let's say we really needed ventilation, but then at the same time, the outdoor conditions say this is a really bad time to bring in that outdoor air because it's like really humid outside. Now you're kind of in a predicament where you have to compromise on one thing or the other. You either might not get the ventilation or you might get more moisture and have to deal with a higher temperature than you want to be bringing in. And so there's drawbacks to that approach where a ventilating dehumidifier says, I don't care really what the outdoor conditions are. I can handle it. I can condition it back to the set point.
Except perhaps fire, forest fire, smoke? Perhaps?
Correct. Yeah. Anytime, obviously, that the outdoor conditions are worse than the indoor conditions, you also don't want to bring that outdoor air in. It's not a good idea.
And what about CO2 control? I think a lot of people are familiar with that perhaps from the commercial demand control ventilation space using CO2. What are your thoughts on that?
our thought is maybe a little bit controversial. We rely on, and we'll explain our thinking behind this, we rely on total volatile organic compound measurements. Why? Why not CO2? First of all, let's just get this out of the way. CO2 sensors are expensive. They increase the cost of the product substantially. And now you have to go sell that increased cost of having that sensor to the homeowner, which is going to create a lot of friction. We're fundamentally trying to make this product accessible and affordable such that it is able to get into many homes. So that out of the way, do we need CO2? Fundamentally, what would we do differently if we had that sensor than just the TVOC sensor? Now, a lot of people have these arguments because they've used a TVO sensor that's maybe cheap or an old generation and it hasn't worked properly. And also there's some nuances where if you don't see ventilation in a long time, if that sensor never sees fresh air, it can start to adjust to dirty air and make dirty air seem like it's okay. And so there are nuances that we've had to work through to make sure that our sensor is one of good performance and our sensor is able to see some fresh air. But that taken care of, CO2 becomes something fairly redundant to measure because we're breathing out VOCs. So there's a direct correlation between VOCs rising and occupancy, humans being in the home. I can guarantee you if you throw a party with many, many people inside of your space, you're going to see the VOCs rise. That's going to trigger the ventilation to increase, just like a CO2 sensor would do. And there's something that CO2 misses. So a lot of people are walking around with these CO2 monitors. They do not capture, the chemicals. It's just the carbon dioxide that we breathe out due to our metabolic process. It does not capture all the chemicals that are off-gassing, which arguably do more harm to human health than CO2. There's some studies on high CO2. There's some productivity impact. But the long-term health, we're talking about infertility. We're talking about very severe things, cancer. I'm a little bit more concerned about that than a temporary productivity loss or waking up a little bit groggy. So that's primarily the basis on which TVOCs seem to cover not only the question of occupancy, but also this question of chemicals that CO2 completely misses.
Yeah, I seem to recall, I might get this wrong, but I think it was a McGill University study like in 1992 that put forth CO2 is the surrogate indicator of indoor air quality after some research. And I think that's just stuck around. And perhaps sensor development in the TVOC area has caught up to that point. So now there's a transition available.
There's also some Mastery Guidelines that got put out on CO2, which I encourage people to read, which does indicate, hey, this isn't a perfect metric for IAQ. It doesn't represent the full spectrum of what's in the air. And also, if you perfectly filtered everything in the air, because CO2 is used as an indicator of COVID transmission, well, if you've perfectly filtered that air, you're still not going to transmit because those were reliant on physical transmission of matter in the air. And so CO2 being high, if filtration is proper, still may not indicate that transmission is likely because it doesn't capture the full spectrum of air quality.
We talked about discount codes before, and everybody knows TrueTech Tools sells this product line. I'm happy to work with Kevin and his team on this. What's the recommendation here if you want to get measure and control? Are there options here in that personal use program? Yeah.
We've definitely, if someone's, and we see this audience, your audience, more on the building science, high performance end of the market. Now we have heating and cooling contractors as customers as well. And we have places for them to buy the product. But we specifically see TrueTech Tools as a good partner for the high performance and building science community. And as such, we didn't want to reveal the online true wholesale price of this product because now as a contractor, your homeowner can go and look that up. And now you have to justify why you need money to buy groceries and pay off your mortgage and do the labor to install this product. It's easier if we can say, hey, here's this online price is X, but now if you use the discount code, we can get it to you for the real wholesale price. And so that's why the initial price looks a little scarier than the actual price we want to give out today, which is 50% off. And specifically on the monitor and controller bundle, because we feel like this community are going to be using the automation and the whole management part of the platform. That's what we see from this community. Whereas some people just use the monitor to understand if there's a problem. That's a good strategy if you're just trying to build up, is there a project? Is there a problem here? Before you sell a solution, like, hey, you need a ventilating dehumidifier controlled by Haven and then the ongoing management by Haven. The monitoring controller is an approach that the building science community seems to take because they already have some of the projects that would use this equipment. But it's valid if you just want the monitor, if you want the monitor controller as a bundle. And then we see people who wanted a second or third controller so they can expand the amount of things they're controlling on that project in that home. And so you can actually have 2 or 3 controllers attached to one monitor. And that discount code, so off the single monitor and controller bundle, is 50% off using the code Haven 2022, all one word, lowercase.
And I'll put a link to the product in the show notes, but you could just go to TrueTech Tools and type in Haven. You should see the products pop up there, populate. And so we're going to focus on the single monitor control bundle. You do go to trade shows. You're out there circulating around. Where's some of the next trade shows people might find you at?
Yeah, there's the ESCO HVAC Excellence event. I'm not 100% sure if we're going to be at the NCI performance event yet. We're not confirmed. We may not be there. We were potentially looking to be there, but those were the next 2 coming up in the next 30, 60 days or so. We were at the symposium. We were at AHR. We're definitely open to, hey, if there's a building science event or a high performance event, we'd be happy to consider going and hearing about it. And yeah, if anyone is looking to also join our beta program and contribute feedback to what we have, or we had Alex Meany just reach out the other day and say, hey, I have an idea. We get all sorts of feedback all the time. We're very happy to get that feedback and put it into a user story and consider it as part of our roadmap.
What would you say the characteristics of a good beta user would be?
Yeah, we've had people come in very excited, but then not really have the time.
That's what I'm getting at. Yeah, be honest. Yeah.
Yeah, so just be honest that this will take some time either to install it, or if we say, hey, we just launched this new feature, could you open this up and check it out and give us some feedback? You do have to hopefully do that so we can get the feedback. And we found that can be a little bit much for some people because people are busy. But anybody who's in the field, anybody who's already installing ventilating dehumidifiers, anybody who's just really ready to do a project like that, has a customer ready to do a project like that, there are some low friction feedback items that we do occasionally request. And that could just be like, we'll send out a poll and say, hey, what would be your threshold for outdoor dew point? What would be the logic if you could design this to achieve ventilation in this situation? What would the logic look like? So we do have some of that where you don't really need to use Haven to contribute and help us.
Okay. And I'm just looking up right here just to give people the price points. The central air monitor and controller bundle is $649 is the list price, but it would be 50% off of that. So that's
$325.
$325. Yeah. Okay. Great. I think I covered a lot here. Any topics left uncovered until next time?
I think just if anyone wants to check out Haven, you can go to haveniq.com. And if you're a pro and you're looking to create an account and get into our ecosystem, it's pro.haveniq.com, where you can sign up for an account.
Would you be willing to put your email address out there in case people want to follow up?
Yeah, it's just kevin@haveniq.com.
Simple.
If you want to reach out for the purpose of our beta, it's just lucy@haveniq.com.
Very good. Okay. I'll try to capture all these in the show notes. Thank you so much for coming on today, Kevin, and wish you continued good luck in your development. And again, like I said at the very beginning, I like this measure, control, manage. That's Eric Preston, my co-owner, and I've talked about this for a couple of years, that we call it measure, diagnose, solve, and monitor. So we had like a little different, but it's that same stream of thinking that we think has been missing from the industry. And congratulations. I think you're starting to deliver that now.
Thank you, Bill. Well, I really appreciate the opportunity to be on. Really appreciate the work you did for the industry.
Thank you. People like you make it easy. All right.
All right. Thank you.
Take care.
Bye.
Thanks for listening to this episode of the Building HVAC Science Podcast. If you like what you heard today and you've not subscribed to the podcast, please consider doing so by typing Building HVAC Science. It's hard to speak, but it's easy to type Building HVAC Science into the search bar of any of your typical podcast apps. We're pretty much all over the place. If you want to keep up on things that I find interesting, you can follow us on Facebook by typing Building HVAC Science or even TrueTech Tools into the Facebook search bar. Some of the topics we discuss require technical training for proper interpretation and or safe execution. So if you're a trained pro, then you can go right ahead. If you're not, please consult with and hire a trained pro. Building HVAC Science is a podcast and a production of TrueTech Tools Limited. In full disclosure, I'm a co-owner of TrueTech. The opinions voiced are those of my guests or myself, depending on who is speaking, of course. I want to thank you for listening to this episode of the Building HVAC Science podcast, where we talked with Kevin Hart about putting the V back in HVAC. And that V means ventilation. Hopefully you haven't waited that long to figure that out. Thanks again for listening to the Building HVAC Science podcast. If you want to reach out, you can be in touch with me at bill@truetechtools.com. Take care.